So if you've ever tried to run, say, a high-resolution 4K video signal across a large room,
Or you hit a wall fast.
exactly, or, across an entire building, standard copper HDMI it dies out pretty quickly, right?
It does, and that's because the sheer amount of bandwidth you need for 4K at 60 frames,
Yeah.
it causes massive signal degradation.
It's just too much data for the medium.
It really is. It's a fundamental architectural problem.
Hmm.
So the solution isn't just a better booster or repeater. You need a whole paradigm shift where you swap those electrical signals for light.
And that's what we're here to talk about. That shift is the active optical cable, or AOC. Specifically, we're doing a deep dive into the DVIGear DVI-2560 AOC Hyperlight series.
Right, and our mission today is really to unpack how this specific technology manages to succeed where all those traditional cables just completely fail.
Okay, so let's get into the performance. What are we talking about numbers-wise?
Well, what's so fascinating is how completely it meets modern standards, but over these incredible distances. You're getting full HDMI 2.0 compliance.
Which means it handles all the latest copy protection.
Yep, HDCP 2.2 and 1.4. And it supports data rates up to 18 GBPs total. That's a solid 6 gigabits per lane. It keeps that 4K signal at 60 hertz with 24-bit RGB color rock solid.
And the distance. That's the real headline here, isn't it?
That is the game changer. These specific cables can push those full 4K signals up to 328 feet. That's 100 meters.
100 meters, you just can't do that with passive copper, not at this bandwidth. But I'm a bit curious, if it's optical, why do they call it a hybrid cable?
That is an excellent question. It's a hybrid because the cable itself has a mixed design. It features 4 polyfluorinated optical fibers, POF, but it also has 6 copper wires running alongside them.
Okay, so the video is going over the fiber.
Exactly. The really heavy lifting for the video data is done by those optical fibers. The signal gets converted and sent over these 850 nanometer multi-mode VCSEL optical channels.
Whoa, hold on. VCSEL, that sounds like some serious jargon. You're going to have to break that down for us.
It does, doesn't it? It just stands for vertical cavity surface emitting laser. Basically, think of it as a tiny, hyper-efficient laser right there in the connector. It converts the electrical video data into light pulses, bam, right onto the fiber.
So super fast and compact. And the copper, then? That must be for power and control signals, since fiber can't carry electricity.
Precisely. That's the other half of the hybrid architecture. Those copper wires are purely for carrying low-voltage power. And it's incredibly efficient, by the way, usually less than 0.235 watts, pulled right from the source device.
Nice save.
And for those essential bidirectional control signals, things like ED and HDCP communication.
Which simplifies the whole AV chain, doesn't it? No need for bulky external power supplies or signal boosters.
Correct. It minimizes heat. It minimizes points of failure. And for pro installers, that's huge. But the actual physical design for installation, that's where I think people are really impressed.
Yeah, I was reading about that. We're talking about routing cable in some really tight spaces.
Absolutely. The focus on ease of use is obvious. First, it's UL-CMP-OF plenum rated, which is non-negotiable for running through air handling spaces in commercial buildings.
It must have, yeah.
But the flexibility is what really blows people away. It has a remarkably small minimum bend radius of just 2 millimeters.
2 millimeters. For
Yeah.
context, that's insane. It fundamentally changes how you can even plan a cable run in tight, confined spots. It's thinner than spaghetti.
It really is. And on top of that, if you're pulling it through a narrow conduit, the connectors themselves are removable.
The actual HDMI heads?
Yes, the HDMI docking connectors come off, and that shrinks the connector cross-section down to just 12.4 by 10 millimeters. It is engineered to be pulled.
Okay, so beyond ease of installation, let's talk dependability, security. Why would someone choose this for, say, a mission-critical environment?
The core benefit is immunity. Simple as that. Because the video signal is traveling as light, the cable gives off virtually zero RFI or EMI, radio frequency or electromagnetic interference.
So it's invisible to environmental noise.
Completely immune. And that's paramount in, medical, government, or military applications when you have strict security requirements and a lot of potential interference.
And it's also TAA compliant, which speaks to that government use case.
Correct. TAA compliance means it's approved for those sensitive installations because it's manufactured in the U.S. or a designated allied country.
So when you put it all together, You have this high-performance, durable, and extremely secure solution. It's all achieved through that smart hybrid optical copper technology and a really intelligent installer-focused design.
The complete package.
So we've looked at how optical fiber solves the classic problems of distance and noise in high-end AV. But given that extreme noise immunity and that specific TAA compliance, it brings up a bigger question for you, the listener. What other security-focused, noise-sensitive applications, I mean, things beyond just video transmission, could this level of guaranteed data integrity completely revolutionize?